Show us your project, second edition. We have 14 participants today, and we have 1 hour, so it's impossible. So we will break time a little bit, and I would like to inform everyone to please respect their time. I will also have this 1 minute, 2 minute flag that I will show, so you know how much time you have left. Okay, and I will, after each person finishes, I will call the second person to come down so we can have quick transitions. Okay, I'll now call names, and please raise your hand if you're here. So Nuri for Parajs. Okay. Christopher. Okay. Iona. Mahmadou. Mahmadou. Oh. Jakob. Dale. Eric. Marcus. Hernan. Okay. Melvin. Bobo. Pavel. Okay. And Milton. Okay, great. So I would now like to invite.
I was also there, but maybe.
Oh, okay. You do have preference? No? Okay. So Nuri, go to the stage.
Did you say 7 minutes?
Yes. So, and Christopher is the next, so he can prepare.
Thank you, everyone. So I want to thank the contributors of Pharo.js to Pharo.js. One of them was Norbert, who already left with, and the other one could not attend is Max Maton, who is the guy here who could not attend, but he did something cool for his company. So he started with Pharo.js, say, okay, cool, Pharo.js can export to JavaScript, but how to deploy? How to deploy? So his idea was, why not use GitHub pages? So he started with GitHub Action plus Smartux CI plus Pharo.js, and whenever you commit your Pharo.js project to GitHub, the CI works and generates the page, the GitHub page, with in the right repository. So, and he did. I guess I need to get the view here. Exit. And so he made some small tools for his that he uses in his daily job. So one of them, he's doing a lot of tests. So he's in, you need to know what is the screen of the page. And if you look there in the debugger here, I need to zoom a bit. You see it's generated the Pharo.js JavaScript generated by Runner, which is the GitHub action thing that runs when you commit. He made the, I don't know, okay, it's generating a name for whatever. And let's say Q, and generates something. Again, it's the same code. And where is my IP? And okay, I need to make it smaller because it should be nicer. Go, and it's supposed to look up. Okay, it's supposed to draw a map. IP 888. No. 8.8.8. Okay. Well, you are taking the DNS of Google. This is the DNS of Google. Okay, okay. For some reason, it was working 5 minutes ago, but okay. So you got the idea. This is the demo effect. So what matters is that yes, he did this thing, and I want to acknowledge what Max did. And from there, we started cleaning up. So we want to make a template. So I did an experiment and spent some time with the help with some people, and finally generate this. So it's reproducible, and we can copy a repository, and you can use it on your own. So it works. That's it. Thank you.
Iona is next.
Okay, so my reveal.js is having a demo effect bug, so I've got to back up here. So I am Chris Furman. I'm a professor at the École de Technologie Supérieure in Montreal, and I do Moose. I'm working on Moose. I spent a sabbatical 5 years ago with Steph. It's already 5 years, Steph. What's going on? Some pandemic thing happened in between or something. So I'm going to show you, unfortunately, it's going to be in the material is in French because I teach in French because I live in Montreal and French is a very important language there. Basically what I want to show you is that we have a importer for TypeScript for Moose. And in the past, there was an importer for Java and some other languages. So I've been working with some interns about trying to get things to work with TypeScript. So, oh, I guess I did the wrong thing. I will just get that back, just clone it. Maybe. Duplicate. So, it's my PC is super slow for some reason. Okay, so the green box that you see is the meta model for TypeScript. So that's one of the aspects with Moose. I don't know how many people use Moose or know about Moose. It's a very small number. So Moose is a platform in Pharo that you can use to model things, but we use it to model software projects. So the software project that I'm interested in modeling are TypeScript projects because you have Angular, you have lots of different projects in TypeScript, it's a popular language. So there is a process whereabout you take on the light blue cyan, you have the code that's in TypeScript and you want to model it, you want to bring it into Moose and look at it. But it takes what's called up there, we see it TS2Famix, it takes an importer to do that. So there has to be something that will understand TypeScript and convert it to a model that you can load into Moose. So we do that in TypeScript because it turns out that's the best tool that we could find to do it. We use tsmorph if you know of TypeScript. So once you get the model into Pharo, then you can model it, you can do visualizations. I'm going to skip to the very end of this thing because I explain all of this with steps. I'm going to go faster because it would just bore you with the steps. I have a person that can testify to the fact that it works. It's Benoit. I demoed it to him at lunchtime. So at the very end, we have, you can see the model has been loaded into Pharo. This is an animated GIF. By the way, this application is sort of the prototype, so it's not all of the information that you would get in Pharo because the importer was limited, but the current version, we actually do a lot more stuff. And then once you have it into Moose, and anyone who's used Moose knows how to do this, but you can do visualizations with, for example, with Rosal. Here is a visualization where we look at all the classes in the project, and you can say, oh, you can map the width of you can say maybe the width of a rectangle is, I think it's the number of variables that are defined in the class. I mean, you can make the visualization whatever you want. In this case, this width is that. I think that the height is going to be, what does it say? Number of lines of code is the color. So anyway, you can do a visualization. And again, I'm showing you a animated GIF of what the visualization looks like with Rosal 3, I believe. And so this was a project that we modeled. It's called Emojiopoly. It's a version of Monopoly in TypeScript that we use as sort of a pet project just to do that. So that's my demo. So thank you.
Okay, hello everybody. So I'm a PhD student at UNRIA. And for those who have seen my presentation yesterday, I was working on reflection and I was doing a catalog. So the next step was, the next question that I had was, now that I have all those reflective features that I know, how can I help people know what they are actually using in their application? If they have a code base, how can I help them to know what are they using? So my presentation today is do I use, and it's assessing how much you depend on features using existing texts. So this relies on the assumption that you have tests already and test coverage that is good enough. If you don't, there have been some great talks about generating tests. So maybe you can go see those people first. So the idea is to leverage the existing tests to create new measures. How much do I rely on reflective features? So this is my question. But maybe you don't care about that because Pharo is a reflective language and, well, you think that using reflection is normal. You don't care. How much do I rely on file access? Maybe you want to deploy an application in production and you don't want this application to be able to access the machine it's running on. How much do I rely on insert everything you want to know about what you're using? So, what I like the first thing, why is it pink? It's blue on my screen. Okay. The first thing is what I require as an input for my script. So this is a script that I built. I need the selectors you want to try. So what do you want to detect you're using? Which packages do you want to study? And which are the test packages that are corresponding to them? So those are the inputs of the program. So what is the program doing basically is, first when it starts, it picks a selector in the list. Then what I'm going to do is to take the packages that you want to study and recompile them and prefix every single instance of this selector that I picked with a prefix. For now, it's like bad underscore original selector. And this means that when the test is going to run, we are going to get a DNU. Does not understand exception. So like this, the test, when I run the test, it will fail. And then I can collect the results and know which are the tests that were using this selector when running. I do that with all the selectors, one after the other, and I get a visualization of the results. So the results I have are like this for now. They're probably like, so here you have on the lines, each line corresponds to one selector that is using in Stone Serializer. So Stone Serializer is using lookup class, isMeta, all subclasses, instant var named, put. And all the columns are the test classes. And if they are completely blue, it means that every test passes, which is great. When they are not, it means that some of the tests failed. And so the idea is to be able to understand which part of your code is relying on what. The problem is that this visualization does not scale great for now. This is the case of Seaside, for example. So there's still some work to do on how to make this information more readable, and I would like also to improve it to, instead of having all selectors at this, like all the uses of a selector at once, to be able to evaluate per call site, which would be more precise. But this is a first approach. The idea is then, maybe after, once I have that, is could we design degrading modes for Pharo libraries? If you don't want, for example, for example, you don't want the library to use some features, you say, I don't want you to use that, can the rest still work? Would that be an option? And so, I don't know why it's looping, but last announcement, I still looking for some people who have opinions on how to use reflection. So if you want to judge other people's codes or give your opinion about how reflection should be used inside Pharo, then please let me know.
So hello, it's okay. So hello everyone. I will be really quick today. This idea is just presenting you a little project we're actually working on at Surat. So my name is Mohammed Bal, and I'm a software engineer, and actually I'm working as an intern at Surat. And today this presentation is about developing a smart game board for Coromas using Pharo things. So for those who don't know what SURAT stands for, it's just the French Agricultural Research and International Cooperation Center here in France. And the problem is, the fact is, a lot of people around the world aren't really aware about the state of environment and renewable resource issue. And this is a big mistake, because these people's interacting with environment without knowing the result of this action. And some people think that role-playing game is a good way to let these people know the consequences of this action in the environment, for example. Because of role-playing game is persuasive dimensions, informative dimension, and educational dimension. So the fact is, actually, we have two sides. We have the role-playing game, where the people are actually interacting manually with the game. There is no automations, and we have some limitations because this game is slow, limited. And the other side, we have full automations with Cormas, Gamma, or NetLogo. Like Alexander presented to you yesterday, Cormas is just a simulation agent-based platform. And the limitation of this side is it's impersonal and inaccessible for some people. So actually, what we want to propose is to merge this both sides and try to benefit from disadvantages. And this point is really important, because if we merge these two sides, we can benefit from real-time interaction. So here is the overview of what we're going to propose. Actually, it's a game board where people's actually moving some object, and the position of each object can be related to some resource or some consequences. So what we propose is just a RFID technology systems that's gonna help people know the exact position of the object and directly send the disposition to our Cormas models in the background. This is the general overviews. And technically, it's about that. So we just have 4 readers, RFID reader, and each reader has to get the RSSI. So it's the received signal strength indicator. And with this RSSI, we can know the position of each object in the board. And by this way, we can know the position of this object and send them to the models in the background. So this is the algorithm we're going to execute in the Raspberry, for example. We just start the systems and identify the ID and the RSSI, and just identify the position of the element in the grid. So the goal of this presentation is just maybe grab some people or contributors who are really interested in this topic and can help us improve the approach. So thank you for your focus.
Hi, my name is Jakob. I started using Smalltalk 1.5 years ago at my company, where we do Smalltalk development, and we also run some tests, and I would really like to have some test coverage. And so I wrote my own test coverage tool. There are a lot of them out there, and this one is mine. You all probably know FizzBuzz. I decided I want to run some test coverage on FizzBuzz, and I just run this run coverage method, and it will print some blurb around it, and the FizzBuzz will output its stuff on the transcript, and then it will generate, well, coverage analysis. I can reload if you so that you can see that it actually regenerated. And you can see that the coverage is not that great because there are paths in the FizzBuzz that we don't execute. So let's just change that to 16 and save and run again. This is not that ergonomic here. So the FizzBuzz runs again, and it writes some more stuff, and it actually should cover all the paths. And if I reload the coverage here, it says 100%, and it's all green. So that's the boring part. What I think is actually more interesting is that it's actually really easy to implement this because, well, it actually took like 4 methods, and I can show you a little bit of it. Let me enable breakpoints here and then run it again. And then we hit the breakpoint at the right place. What I did to implement this was, well, I work on a compiler project. I have experience in compiler, so yeah, I just used the existing compiler infrastructure in the Smalltalk runtime, which at this point, you have the old source, which is just a string, which I can fetch. And then I can run it through the compiler, and I get an AST, as an abstract syntax tree. This is the serialization of this tree. You can see that this is an ES method, and you can like check all the objects in it. And then what I did, this is one of the one of the 3 methods. The second method creates well, I can show you. It creates a marker, right? This marker method called. The first method, this is the first method. The second method creates a marker. The third method tells me whether something, some AST node contains a block somewhere in some method call arguments. And the last one, well, what it does is it inserts a marker at the start of a method, at the start of every block, and after everything that contains a block. So, well, and then you can run it. And the actual hard part in terms of lines of code is taking all the markings, like taking these numbers here, which are like turned into bit flips in the bit set, and then reverse engineering lines of code and position in the source, and then visualization, right? This is actually the hard part. The thing you would think is the hard part is actually pretty simple, which I thought was cool. How much time do I have? 2. Okay, well, I think I'm done here. So yeah, if anyone has a question.
So I'm in this talk because Oleg told yesterday that he needs some people to do a talk, so a presentation of. So that's why I'm here. So do you like to explore packages in GitHub? Like, yes? No? Okay. No, but I like it. So one of the things I do is like to search for the tag GitHub and then explore some packages. For example, this one, and then you, or I at least, copy the Metacello script. You know, Metacello is a package management system for multiple implementations of Smalltalk. And then I came here and open. This is uncomfortable. Yeah. Just patience, please. Patience. So you paste here and you evaluate. And this is like you do this like a lot of times, and this is becoming an addiction actually, right? It's surprisingly funny. And so the idea is that I kind of developed this. He's here. So this kind of UI to organize the Metacello scripts, and it's super simple to do it with Spec2 now. And this with total lack of inspiration, I call it package formulas. And but the idea is that you can define a formula, and it's just a method. You put a pragma, and this pragma defines the classification here. Like everything is dynamically collected, and yes, over here that you select the packages that you're interested. And you can install with options. You can directly install, and you can like do this kind of pre-evaluation stuff. And for example, a profile or benchmark or disable the monitor, and this is automatically. And from here, like you could select a lot of things and just copy and do like manage your own stuff. So it's pretty simple, but I found it like useful for me because I don't have to copy and paste all the time. And the idea is the formula is just a pragma. It's a subclass of pragma. What it is? Okay, it's over there. So it's super simple, but if you like it to organize your projects, you could just develop your own set of packages and use for your own MetaShell installations. So that's all I got. Sorry.
So I'm going to talk about three things. Oh, I think I left my mouse. Okay. All right. So I'm going to talk about three things today. I'm going to talk about SuperDoit, GSDevKit Stones, and Rowan. All right. So I'll start with SuperDoit. It's a framework for writing and running scripts using Gemstone Smalltalk. This has been a bugaboo of mine for probably, I think it gets close to 10 years. All right. And it's related to GSDevKit Stones, which is a replacement for GSDevKit Home. And when I wrote GSDevKit Home about 10, maybe 15 years ago, I ended up using Pharo as my engine for running command line scripts because it wasn't possible to do that in Gemstone. Because in Gemstone you have to have a stone before you can run your code, your Gemstone code. And how do you install a Gemstone? Using Gemstone, all right? Well, you can't do that. But a few years ago, solo scripts or solo extents were created that allowed download Gemstone, and you can run Gemstone scripts without having a stone running. So, so that was an important part. And then GSDevKit Stones is a rewrite of GSDevKit Homes because the Pharo script was only one part of the problem with GSDevKit Homes. It was way too heavyweight. And if you've used it, you know what I'm talking about. And if you haven't, well, wait until you get GSDevKit Stones before you start playing. And then the third thing I want to talk about is Rowan, and that's a package manager for Gemstone, and it's the next generation of Monticello and Metacello, providing a full-featured development environment for Gemstone, all right, which we don't have an official Gemstone development environment at the moment. So going back to SuperDoit, I'll show you what I have. If you were at in Cologne, you may have seen my presentation where I talked about taking tunnel files and turning them into scripts. Well, you know, it was a neat idea, but it's not. It doesn't actually work. And this is kind of the replacement now. So SuperDoit Solo is actually telling Gemstone to run a Topaz against a solo extent without running a stone. And the nice things that I like about this is I use command line options all the time. All right, and this is the list of command line options that you can get in SuperDoit. And so. What you notice is this is actually like a literal array, all right? And this options block is terminated by a %, all right? This happens to be commented out at the moment. But now I've got a usage block, and this is the other part of scripts that has been my bugaboo. This usage up to the % is defining the help for the script. I don't comment my code if you read the stuff, but I comment scripts, and it's easy to do, and it actually helps me. Whereas I can read code, and I'm sorry, that's not an excuse. And finally, there's a do it, and I left the % off the bottom. But basically the do it is the body, and this is what gets executed when you run this script. And you can actually add local methods and instance variables. You can add blocks for pulling in, for using Rowan to load projects from the internet, all right, into your script. So, you know, there's some really nice features that allow you to build scripts that don't have all the code in it and use code that may not even be on your system, okay? So, and so the solo scripts run with, without a stone, and of course there's a variant that runs with a stone. And this is an example of an error. This is a minimal script for doing a stone, and it's SuperDoit Stone that runs with a stone. And there's rules for names and things like that. I won't go into the details, but I will show you that if I run error stone with a -D option, which is a default option for debugger, you end up with a Topaz, all right? And if you're not familiar with Topaz, you might recognize a Smalltalk script. And then I'm looking at frame 7, which is the executed code, all right? And the does not understand comes from that. And when we look at it, there's my 3 foo, and so now you can debug these scripts dynamically in line in the shell as you go. So that's kind of cool stuff, and as far as I'm concerned, because it's been a dream for a long time. So now GSDevKit Stones, I mentioned it's, but it's been built on top of SuperDoit. So SuperDoit enabled GSDevKit Stones. And I think the key feature here is that you can define a registry of locations for various gemstone artifacts in the system and decide where you want things to go. And this is an example of what the registry looks like. And here's a list of where the information about a particular stone is stored. Here's where the stones are all created. Here's a list of products that are downloaded. So this is multi-stones, versions of products. And so this really can make it real easy to manage a distribution of gemstone. And finally, there are the solo scripts for listing the stones that are in the system, starting a stone, stopping a stone, and NetLDI is one of the pieces of this gemstone architecture. And finally, I'll just really quickly show you that this is Jadeite for Dolphin, the development environment for Rowan. And you notice all these red guys down in here. This is where there's a skew between the loaded version of the project and the version on disk. So this is a red situation. So this is Jadeite for Dolphin, and here's a picture of Jadeite for Pharaoh, and it's running in Pharaoh 11. And I think I'm done.
So I will show you a small project integrated to our repository OpenSmoke, because one of my colleagues often says, "Oh, Eric, I have some problem with my Pharaoh image. I just freeze it." Okay, we are talking just before about do it, and we say, okay, what did you do? I just started to open a playground, and I run a test, and my Pharaoh image was blocked. Okay, so we can reproduce it very simply. You have here, a simple playground with this kind of thing. 20 seconds wait. So you play do it. Nothing happens if you try to open other things, it's blocked. So, okay. Sometimes it's not just waiting 20 seconds, so I have to wait just right now. But, okay, sometimes it's a call more complex, it will not stop, and you have to kill your Pharaoh image and restart it. So, okay, it's over. What I proposed to my colleague is, okay, I will integrate a new mechanism in the playground. So, what I've done is to integrate to OpenSmoke. I just load the good part. This is the EDE part of OpenSmoke. So, no, load it. It's loaded. Now, if I open a playground, you notice differences, maybe. There is a small cancel it button, and the do it button is the same. But if you load this one, now you do it, and you're still able to move in other parts of your Pharaoh image and continue to do it. I can cancel the do it. It stopped, and it says, okay, it stopped. You can go back, do it again. If you redo it, it is okay, I terminate previous because you want to redo it. So I will try to do something fast because 20 seconds. Okay, so it's running, I stop it. You see the text is moving also on the top of playground. I just play it, so now it's running. And no, 20 is 2 more. So I'd say it's 5 seconds wait only. So I played do it, it stopped with information, it waits 5 seconds, and it terminates. And the 20 was aborted. So my colleagues say, oh, okay, that's better because it does not block. I don't know if it handles all the problems of, multi-threading things about changes and something like that, but I think it's a good start to have things like that in Pharaoh. So I wanted to share it with you. You can just use the repository if you load OpenSmoke IDE part, it will load it in your Faro image, and your playground will have the new buttons to maybe to test it and to enhance it and propose amelioration if you want. So thank you.
So I will talk about this context in the debugger. Because have you ever inspected, printed this context in the debugger? So it's actually quite kind of interesting. This piece of code is a method that stops because because it's the method with the name example. So it checks if this context method is selected as example, then it stops. So then you are in the debugger when clearly this context method selector is example. But if you then evaluate that expression, it will be false. So if you inspect this context, it actually is not true. And that's really strange. Yeah? So, and the reason is that this context is actually the context of the do it. Because what the compiler does, it says it sees this context and it just emits push this context as the bytecode. And that's the do it context. So that doesn't work. But in FAR12, if you do the same, it actually magically does exactly work correctly. So that means if you inspect this context in the debugger, it actually is the context that in this case the debugger looks at. And it is fixed for any do it that has the context inside, for printed, for inspected. How is this done? So you might know that in Faro variables are actually described by objects, and of course this context is described by this context variable, which actually is the one that when the compiler tells this variable, please generate code, it just says, oh yeah, I know how to do that, let's push this context. And we don't want that. So what we do is we wrap it actually into something called doit variable, which adds the context as an addition. And this doit variable actually does emit then when the compiler tells the doit variable, please emit your code, it actually pushes the doit variable on the stack and sends read. And this one returns the context that is in the doit variable. And that's it. And this way, this context in the debugger is correct. That was it.
I guess we'll just deal with this. So I'm just going to talk about what I've been up to during this conference. So the first thing is there's actually a really old thing in Smalltalk that I didn't see in Rosal. So we're hacking it in now. And by we, I mostly mean Milton. So the old thing is that when you have an animation, yeah, you want to be able to step through it and then just be able to go by it frame by frame. This is not a thing in Faro. It is hopefully going to become a thing in Rosal. What we hacked together so far, or at least on my machine, is that when you open up the debugger, well, wait, let me first show you the example. So this is the animation which was actually made in the Faro days 18 months ago. And then if you want to debug that, right, then let's see if the demo gods will help me here. Now we have a slider. And the slider, as you can see in the code, I actually interpolate that particular sinus thingy, and that's painfully obvious. And well, that's handy to know. So this is what we hacked together so far. There's also a debugger thing attached to it, thanks to Valentine. I just brought people together and said, please do this. So that's one thing. The second thing I actually want to talk about is another thing I've been obsessed about the past 3 days is creating a web scraper to find cheap flights. And I'm not going to tell you how to do that. I'm going to tell you the troubles that I actually went into to make it, because there are a couple of things that I think are simply interesting. The first one is, so for people who want to know about web scraping, you create this with a library called Parasol. And let's scrape some flights. So this is Google. We all know it. We're going from Amsterdam to Crete. because I think it's a nice place. Also, I think I'm becoming slightly religious now to the demo gods, but yeah. So we are at the page with all kinds of data loaded in. The first issue that actually came about is if you want to inspect elements via Parasol, the issue is that if you do that naively, you get a BP, I don't know what the B stands for, beach parasol maybe? I don't know. But the problem is that you only get a self, an element idea, and the Chrome driver, but you don't get any data on like what is this element, so you don't actually know what you programmatically selected here. So there are a couple of ways in Parasol to fix that, but I think there are actually handier ways in certain cases. And the most fun one that I came up with is actually to just say like, you know what? We're going to send a script and we're just going to color all the inputs. And when you color all the inputs, you get array positions and the colors. And now you know which ones of those array elements are actually visible. And it's really easy to just see like, oh, it's that color. Now to do this, I had to create a custom view. I thought this was too small and I made it bigger. This took me 10 hours. I will explain you how I did it, but not now, because ultimately I realized this approach is a little naive. And I realized we can just send it back to the console. So now we have still the elements, but now we have a timestamp. And then with the timestamp, it's now logged back into the console, same timestamp here. I'm not sure if you can see it, but what you can see is that when I now hover over, it doesn't work. Thank you, demo gods. Let's do it one more time. This happens sometimes. So, and now you can just hover over, and you now know, because it's the same thing server side as in client side, exactly which elements you've selected. So it's really easy to be like, oh, I actually selected the right elements. Because in Parasol, the easiest way I find to select elements is by using XPath. You have to become a bit of an arcane expert in that, but once you do, and you do this, it's super quick. All right, what else have I been up to? Well, like I said, this thing, creating this was pain, a good lesson in pain, because this is how Pharo allows you to do it quickly. So I'm just going to show you how I did this, because there might be some interesting lessons there. It's hacked together. Is it good? I don't know, but we'll see how to create an inspector pane. So we all know that we have a pragma, or I think it's called a pragma. This thing here. And inspector colors tool is the old one. So basically, this is how you create the the normal version of with the small font type. The thing is that if you want to have a bigger font type, basically you need to adjust the evaluated block and basically create a new string morph in that. Now to me this is arcane magic, but that's one way to do it. How do you create a bigger font in the first place? Logical font, family name, and then the point size. Also, how do you get the row height of a table inspector view bigger? Almost 1 minute? Okay. Well, the answer is you have to know this particular selector and then this particular, yeah, and you just need to know that it's a morph, and then when it's built, it's done, and that's how you make that bigger. Now you know, you will forget it, and then at one point when you're 4 hours in, you might remember. Final thing that I did was I wanted some type checking, because sometimes, especially with dates, also at my work, I don't know if they're strings or dates or whatever. So my favorite selector, the underscore colon, is one way how I did it. And my other favorite selector, the exclamation mark, is the way how I did it. So is a day to day a string? Well, let's print it. Of course it isn't. And is this a date? Yes, it is. And it's optional. And it's just a really quick way to hack it in. Because this is the whole method of it. And I needed to use it in particular here because, and I do it like this, so kind of, I don't need to look too closely. And by doing this, I don't need to worry about if it's a string or if it's a date. It will crash and then I'll fix it. Yeah, that's what I've been up to the past couple of days. Thank you.
Hello everyone, I want to show you a tool that allows to implement a software product line following delta-oriented programming paradigms. So I want to explain some concept before to show you my demonstration. A software product line is a set of software that share common characteristics, but we can play with feature to create a specialized product. And that here is an example. We have a product line and we can create a set of variant by reuse. And for that, we rely on a domain feature model that represent all the available feature that allow us to create software. And that is a practice example. So we have a reusable part and we can create several things. The interest is that it avoids some bad practice caused by the manual cloning on practice, because sometimes you have many projects that are similar and we maintain each project, test each project many times. And the interest of using a software product line is that we can test and develop only in one localization and after we can reuse. And we have many implementation paradigm, and our tool focus on delta-oriented paradigm. It works like that. We have a core product and a set of possible change that we can apply to a product. We call that delta modules. And these delta modules are created following our feature model. For example, here we have feature 2, which is optional, so it can be present or not. So we can have a delta module for remove or add this feature, and we can have our product. That is an example. We have a Java class and a delta modules, and that will add some an attribute and a method. So it is difficult because the objective is of using SPL, a software product line, is to save time, and in this case, at large scale, it is difficult to maintain delta modules, and we don't have many tools for that. We just have Delta Java and just support Java 1.6. And our tool work at model level, and instead of having Java class, we have a meta model of our software and we can apply delta modules. And after that, we have a variant of our meta model, and we will use a Famitsu Java project created by Benoit Verag and Gabriel, and after that we can generate a code. So that is a demonstration scenario. We have delta modules that is represented by a internal database, and we have version of delta modules, and we want to remove an entity. For example, here we don't want Kafka broker. And for the demonstration, what time? And so, 3. We have several packages. We have a delta model package that represents the model of a delta module. It is represented by this database. Here we don't have anything. And we have delta manager that have methods to modify instance and class side method of our generator. And we have some presenter that represents our application, and IHM for update, create, and apply delta modules. And in this example, we go from this meta model. I don't want to delete this, and I want to create a meta models. And like I said, here we have many things about Kafka configuration, Kafka, and we don't want this entity. Okay, so Kafka again, and we launch our application like that, and we have a button that allows you to choose if we want to create, update, or apply a Delta module. So we want to create a Delta module, and we need some information. For example, here we have to remove Kafka. I have Kafka config. Sorry. I want an operation I want to remove. And that is just for the package name. And that I have the generator and the initial package. So here I create a Delta modules, and I can show my Delta modules in my database. And now I can apply this Delta module, and for that I have apply Delta modules, and I want to remove Kafka broker. I can apply, and I show in my here I have I don't have Kafka here, no hierarchy, yes, and no properties, etc. So we can generate, because we can generate our model, our meta model, and we have there the good package with and we don't have Apache Kafka there. So we want to generate the code, and for that we use Famix2 Java. And for Famix2 Java, we have a JSON input that create link between classes and reusable artifacts. We iterate on each class and create attribute, method, annotation, and inheritance, etc. So if we execute that, so I didn't show you that it was nothing, but you see, I just create them. I create them, and for example, you know, it is not finished. Sorry, 1 minute. Thank you. So I generate the source code, not complete. For now, I don't have a report. And we can visualize the Delta module, and we have inheritance. And we can say
this time I will talk, and Pavel spends the notebook and guides through the landscape of Faro. On Tuesday I had a talk about command line reinvented, and mentioned in one sentence that we have one-time tests, and I want to show you a bit behind that one-time test. First, we will execute one one-time test. So for that, we just press a button in our scripting test class, and the test executes. That's a kind of test that does not, intentionally not modify the database. So if we close the same thing, reopen it again, select the same position, it's empty, and we can execute it a second time. So that is the story of how it works, how it looks, but more interesting is how does it work. So first interesting thing is it looks like a test case, but it's only similar to it. It has a different button, as you can see at the browser. So we take my glasses off because I can see better. We intentionally did not use the testing environment, but created a simple environment because, as you know, every test run removes everything and cleans everything up, which is not suitable for long-running scripts. And Pavel invented a new pragma to allow us to have scripts also on the instance side. So, but for now, Faro by nature only knows scripts on the class side because it's then easy to find the context. but we hacked a bit, or Pavel hacked a bit, to make it possible to run a script on the instance side. And the trick is we use the implementer method selector to know what we have to run and create an instance as we would do it in a normal test setup. So that is our trick, to be able to run scripts on the instance side and reuse all things that are good for the testing environment, but not use the obstacles that we would get by the way that the test wants to clean up everything afterwards. So, next thing, how does a typical test for our command environment look like? We saw that we created a folder along with 10 documents. So for making it a bit simpler, we see how does a script look like that for creating a single folder. That is, we have to go into the create folder create call under the parent folder. We assume that we have a parent thing above, and here we have several variables to be filled. That's a placement, so where shall a new folder be created? Then the folder has to get a name, and here you see why we use the language and not just create testing calls by assembling strings. It's much easier to express yourself in the programming language to create a call instance, because we have only strong typed values that we use for the call. So that is a very simple example. You see the call object is created. We have 3 call variables, and below the call you can see that it also activates tracing, and you can do everything you want. That is the call object that we create. And finally the call is executed, and we wait for the result because every call is internally queued. So that is the story for the call object, how it's created. And the good thing of that is that we have a lot of reusable code, because I can use the same story for a lot of tests. It's very handy to read the code. You can easily see what it will do. And now we could show the resource methods that we have here, or have a look at the big method that we were running before in the documents class. So, not a document, that one we were running. So I used a lot of variants of that course, and that's another good thing. You normally know when you write tests, it's very hard to find reusable parts of what you implement. In that case, as we know, we want only objects to be created. It's quite easy, and in that case, you see it's straightforward. We have a parent folder, create a folder and execute it, and please go down. And then we see the loop 1, 2 document count, it's a parameterized value, and do it, and then everything is done. And we're very happy with that possibility, and we'll use it to really extensively test our command line interface. Many thanks.
Hello everyone, my name is Milton Mamani. I am software engineer. So today I want to talk about GitHub Actions. And I don't know if you know, but GitHub Actions are pretty cool actually. There are many things that you can do, especially for testing. So many of us usually we use GitHub Actions like a Smalltalk CI. Where is it? Oh, yes, like this repo. And it's a pretty cool project, but sometimes you need something that is more specific that you cannot ask for the people of Smalltalk CI. Like for example, draw a simple visualization of your code. you want to do that every time that you have to do a commit. So it's kind of easy to create a new GitHub action, actually. So you only have to create a repo. And in this repo, as you can see, also you can use Visual Studio Code here. You can only have to put dot, and then you can start to editing your repo from the web browser. And then you have to create a JavaScript file. This JavaScript file is going to have some inputs for your GitHub action. And with this code, you technically can run everything that you want and generate files, processes, whatever you want, actually. And then I uses this so I can generate my test code, and I can download a Faro code, and all this process is going to be managed by the GitHub action. And here also you need this other file to define the inputs of your action. And then that's it. You can plug also Smalltalk code here if you want. In this case, I just put Smalltalk code to testing. And the final step is that you have to define your YAML file, so you can describe how your action has to run, how you can use this action. And as you can see, it's kind of simple. Every time that someone is going to push something in my repository, it's going to execute these jobs, where I can cancel the last execution, and then I can download the repository, and then I'm going to use my new GitHub action. As you can see, you have to create a pre-release of this action, so you can use it from other repositories. And then, as you can see, now I can use my own custom parameters, and this is going to be executed on different machines. In this case, I set the machine for Ubuntu. And then also, because this process creates some files, you can store these files. As we saw in the presentation of Pablo, you can create pictures, but you can also serialize objects if you want. So then after, you can use these objects and see what happened. So because the time is short, I only can show you here, well, not this one. Okay. Yeah, the actions are here. And then when you do a commit, you are going to see the process of all your jobs, the things that you define in your GitHub actions. And the pretty cool of this is that you can see the process even from your phone. So this is for me amazing, because you can see how your Smalltalk code is running from this part. And yes, you can see all the steps that I define it. And this is my process that I define it. And it's loading code from Smalltalk. And it's creating some pictures of that. And finally, I can see that also has created the pictures. And you can access these pictures, if I remember well, from here. Yeah, it's called assets. I call it to download. So now I can download. Okay, I can open it. And this is the image generated by the Smalltalk CI. Well, not Smalltalk CI, my custom Smalltalk CI. And yes, that's it. It's a simple process, but as you can see, you can do many things with this, because now you can generate things that then you can download to compare in the testing, to know what is happening in the server side, or even to create products or executable software that then you can use it. So that's it.
Yes. So yesterday, maybe you saw that I was creating some slider for my performance. It was done like in 1982 with Morphic and some very basic and primitive stuff, but it was working. And today I was talking with Pierre and Eric Otales, and we were talking about maybe we can do these sliders with block. And so in the very few time we had, we tried to do this with block. There is this slider that is a subclass of a block element, and then we made a block element that is a container, so we can add all the
slider we want. And then the slider have minimum value, maximum value, and also there is this cool thing that is like we can have enumerated values, so I can decide like the nodes for these events. Now, if this work, oh. That's all for me.
Okay, so I try to present you to WebView for VisualWorks. If you were here on Tuesday, you probably heard Marianne's talk about WebView for Visual H Smalltalk. And I can confirm that it's a need for software companies like us that have quite old, 20 years old GUI application and try to switch to the modern world and use browsers. And new modules are developed, Seaside, Angular, whatever. And existing customers need to embed, for them, we need to embed them in our existing GUI application. So we have our existing GUI application. I'm quite unprepared. I just decided an hour ago to do this presentation. So we are already, I just opened a window of our GUI application. Sorry for that, I didn't prepare. So this is our GUI application and it's embedded in a widget that just displays WebView 2, the Microsoft Edge engine embedded in our widget here. So you have the same thing here. It's Firefox in the browser. So, as you see, same application in the browser or in our widget. And another cool thing, it's a browser engine, but it's not that you only invoke something in the browser, but you also have interactivity with the browser. If I switch to something different, we're in the health sector, so we have documentation of wounds. And this is a mobile module also. It's a Seaside application that you see here. But you can invoke something here and, oh, okay, it's a reporting error. But you see the VisualWorks dialog window. It's a callback into the image, and the image spawns the reporting, and the user gets it presented in its GUI application, although it was started from a mobile application in this widget. So that's it.
Okay, so now you see Cormas. So many of you who assisted to my presentation have seen the ESUG model, and now I will show you the small version of this model. So now we open it like this. Yes, you see in this model we have two kind of foragers, two kind of cows who eat grass. So the restrained and unrestrained. The red one is unrestrained and the blue one is restrained. Now we will do a small thing. We will try to control these cows with our smartphone. So on smartphones there are chats such as WhatsApp, and there's also another chat called Telegram. So I have created a small Telegram bot that allows us to control these cows. So to do that, we open the playground, and first of all, I need to get this model. So I say ESUG model, all instances last, and they should give me access to the object. Now I initialize the Cormas boards. Okay, I start it like this, using my very secret token. So please don't, yes, please don't look at it. Okay. And now I execute this line. Okay, sorry, I forgot to execute the previous one. Yes. So I can actually execute all of them at once. Aha, like this. You see, so now I have this Cormas bot, which is running and which started pulling. So then I click start here. You see, it is like, this is like the screen of my phone. It's the same but on a computer. So I typed a message start and it tells me, hello, I'm a Telegram bot written in Faro, and so on. So now what I do, I write connect. And now it connects me to the session ESUG, to this session. And now what I want to do, I want to control one of those foragers. So I will select, for example, unrestrained forager. So I click on it and it tells me, okay, my ID is 1. So what I do, I write control unrestrained forager, so the class name, space 1. And it's telling me I'm controlling unrestrained forager with ID 1. Okay, great. Now I can send some comments to this forager. I can say, for example, move. Ah, nice, right? I can also say eat. Wow, okay. Move again. Cool. I can even say inspect. You see? Okay, now let's try something dangerous. Let's try to connect another phone. So I will ask a very random person, Ernan, to please. Yes. No, you don't need to enter the ID. Actually, Ernan will try to control the other forager. So he will control the restraint. So he needs to write, we check the ID for restraint, it's 1. He writes control restraint forager 1. And now he can type, did it connect? Yes, now he can type move. And you see now we can do it simultaneously. I can move mine and he can move his. You see they move at the same time. So like this we can use this kind of applications to have participatory sessions between many people who can control and play with agents. Thank you very much.